If you know the rules, you're in good shape. If not, then you will be in good shape. It's not this moment. Later on in the course, we'll learn where these rules came from and why they work the way they do. But we actually have to learn something called a derivative first before we can actually. All right. So all we're trying to do here is manipulate the given expression to fit one of the given rules. So how hard could it be? Extremely hard. No, in certain circumstances it's not bad. In other cases it's terrible. So let's do a case where it's not too bad. So looking at number 1, it's not too different from that first rule listed above. We got some extra stuff there that we don't need. The 3 and the 2. Less. One of the properties of limits tells us that if you have constants, they can be factored out of the limit. So I'm going to pull out folks, just so you know, when I'm recording, all your intelligent thoughts could potentially end up on a video on YouTube. So keep them coming.
Are you recording as of right now?
As of right now. So, especially if you're in this neighborhood.
Hi, YouTube. I want to be on YouTube.
Well, no. So I pulled out the 3 halves, and now I'm left with this guy, which we know is equivalent to. You talk it every other time, for crying out loud.
So is this like similar to EBM?
Not even a little bit.
Okay.
Yeah.
Ignore me.
You're getting roasted in the comment section.
We'll have to come up with like 10 names so that YouTube could know us by something other than who we really are. Yeah, so
That's great.
you see this right meow?
Yeah.
And see that right meow? So the answer for this is, that part anyway is 1. The final answer would then be, you guys are costing me years on the back end of my life right now. 3/2, yeah. All right, so very, very easy. Until it's not.
Okay. How'd you just like get rid of the limit and everything?
So you see this right meow? And you see that right meow?
Yeah.
You see how they're exactly the same except this guy has betas and that has boom.
This is
It's like black magic. So how's boot number 2? We don't seem to have a tangent rule up there. And just bear in mind, these are all trig related problems. These rules could come into play, but maybe it's something even simpler. Maybe it's just general knowledge of trig. How hard could that be? So what do I do first? Change the tangent. Yeah, change the tangent is what I was trying to say. So we have the sine of theta. Sorry. I know I can't be entertaining all the time, but I try to be. I try to be. I guess a yawn is better than a belch. One time a student did that. Just let out a loose one in the middle of class. It was like one of those throaty ones. It's gross. What does this simplify to?
1/9.
All right, so I'll write the intermediate step.
Wouldn't it be like 1 minus? I don't know. Don't ask me.
Nice.
Because keep, change, flip is a thing, right? Still, believe it or not. Cancel the signs. And it's like, wait a minute, we don't have a rule for that. Oh, I gave you 4 rules above. None of them say just cosine. So what do we do? I'm so scared. Any thoughts?
Plug 0 in for theta.
Oh, there we go. Ah, that's my big bugaboo here. I got to remember to put it back to regular marker. Cosine of 0. Now the big question. What is the cosine of 0? All right. Gap? Was there a foldable for that?
What are
No.
foldables?
They're just like colored pieces of paper that have a lot of information.
We might
but
have
you
to
fold
do-
them, and like you can just not fold them, and they still have the same information.
The whole part of it, like it implies that you don't actually have to do the folding and you still get what you need. Maybe we'll do like an in-school field trip to Miss Hamilton's room one day, just so the pre-calc people can get a little bit of a taste
I kind
of
of
what
want to
this
know, like,
foldable stuff
I don't know what it is, and everyone uses them, and I'm just like, oh, something.
Yeah.
I can bring some.
With Tom, it was like, remember what you failed. Yeah.
You shall. So here we're looking at an expression that kind of has some characteristics, and this is probably the most important one because it doesn't look like you can really do a whole heck of a lot, but there's a lot you actually can do. One is actually to factor, because this is a difference of perfect squares on the top. You could also break it up, and it's weird to think about limits when you have a product within a limit. You can take the limit of each of the separate factors of that product, but that's a different story for a different day. So what we're going to do here is we're going to start off by factoring, and we're operating under the assumption that just simply plugging in the 0 is not working out for us. Right? I've been skipping that step. But if I plug in a 0 here, I get a 1, right? 1 squared is 1, 1 minus 1 is 0. I plug in a 0 on the bottom, I get a 0. It's indeterminate. It tells us that we can do something algebraically, rule-oriented, trigonometric, that in order to get a limit that actually exists. So that's what we'll do. Factors of the top. I'm just rewriting the bottom. Factors of the top would be what?
1 minus cosine theta, 1 plus cosine theta.
Indeed.
I'm redeeming myself here.
That's a clutch performance is what that is. Got a clean cancellation, right?
It's gonna be like that.
All right, now just looking at this, if I were to go and punch a 0 in again, it would seem like, oh, maybe this is a DNE. I don't know what to do. Plug in a 0, you get 0 over 0. Yeah, you look above. Extreme close up. Whoa. Bringing it back, bringing it back. By rule, it's equal to 0. So let's make it more than not quite. Let's make it quite. So I got a power of 2. That means that I have sine of theta times sine of theta. All right. true statement. What I want to do is I want to manufacture the rule from this expression, one of the rules from this expression. Now I have a sine of theta over theta. When you look at my answer key online, you'll see I use a little shorthand notation. I use a lot of shorthand notation. So I'll do it the longer way here so you get a feel for it, and then I'll show you how you can kind of cut corners a little bit. All right? The idea is that you can break up the limit based on the factors. And also with an eye on what you want. I want out of this, the limit as theta approaches 0, I want to make sure that I have a sine of theta over theta times, separately, a sine of theta. Now I'm going to apply something called the product rule for limits. I tend to overuse rules. There's product rule for logs, or when we get to derivatives, there's product rules for everything. This one's specifically for limits. It tells us that if we have a product contained within a limit, so this is the limit of these two things multiplied, so thinking of it like this, and this doesn't seem like it could possibly be correct algebraically, but it is. It equates to the limit as theta approaches 0 of the sine of theta over theta times the limit as theta approaches 0 of the sine of theta. That first one I bracketed off there, what's that equivalent to? 1, that's one of the rules. The other guy, or gal, look at it and say, well, we don't have a rule for this. When you run out of rules, you can default back to prior knowledge. Okay, we don't have a limit rule for this, but we have something called trig that you can use. It's a very powerful technique. Specifically, unit circle, heart chart, if you're a heart chart person. Although, by the time the course is over, you're going to be like, all right, forget about heart chart, unit circle is where it's at. You'll see why. It's not me being picky, it's just one is better than the other, and you'll see why. All right. So this ends up being, I left it on highlighter mode. Sine of 0. Do my substitution. What is the sine of 0? Outstanding.
0.
0. There it is. That'll come quicker as the course goes on. See what we got. Well, let's start off with the thing I neglected before. What is the tangent of 0?
0.
0 over something, right? So
Over 1.
exactly. Remember, tangent
Sine over cosine.
opposite over adjacent, but also sine over cosine. So a good way to remember where tangent is equal to 0 would be wherever sine is equal to 0. Okay. Tangent's undefined wherever cosine is equal to 0. So if you know your sine and cosines, then you indirectly know your tangent. 0 or 0 or 90 for
Oh wait, not 90,
0 or
180.
yeah. Anything on the x-axis. All right, so let's dive in and see what we got. I see a common factor on the bottom. It's never a bad idea. What does Miss Hamilton say?
About what?
Common factors? Actually, she doesn't say it.
Oh, what's the first thing we're frequently after?
She doesn't say it like that. Oh, come on. You got to do it the right way. She used to, oh, well, you guys know this, right? You're right across the hall. Because she'd come into this class, tell me to come over to your class, and say you're going to do stuff. Or,
Yeah, I thought we were gonna do number 7. What?
really?
You were like on it.
Yeah, I know. I was going on a tangent. So, unintentional pun. So, if you're looking at this, and this is the shortcut I was alluding to before, let's go back for a second and take a look at number 8. This is very important. Hugely important if you're looking for something that'll save you some time. We got to this step, and then we went through all of this stuff here, which is all very valuable things for you to know. It's rigorous math, it's how you go about proving things, but we're looking for an answer. We're looking for a streamlined, efficient approach to get an answer. So that being said, what really ended up happening is the part of this that ended up being our rule, the factor that ended up being the rule, got canceled out, right? Because when all is said and done, we were just left with a sign of theta as part of the limit. So we could have just wiped this out right here and jump right down to this step. So that being said, how's about we do the same thing right over here? So we got this component here that constitutes our rule. Again, only because theta is going to 0. So that's going to go away. Limit as theta goes to 0, 1 over 1 plus tangent squared theta. At every step, I know it's frustrating, annoying, and it definitely takes a little getting used to, but at every step along the journey, you want to be thinking, can I substitute now? All right? Well, can I?
Yeah.
Yeah, totally.
Sine squared theta over cos squared theta.
So, well, even more elementary than that. Like actually a numerical substitution.
Oh.
Completely reliant on your knowledge of trig ratios. Tangent of 0 is equal to 0. 0 squared is 0. Plus 1 is 1. 1 over 1 is 1. So that's our final answer. All right.